In algebra, we want to simplify as much as possible before moving forward. So here we have a fraction that we can simplify. Step one, when we're simplifying fractions, is just to factor out the numerator, which is the top, and the denominator, which is the bottom, as much as we possibly can. So that's our first step. Let's go ahead and do it. For the top, that would be 20 divided by 2 is 10. Divided by 2 again is 5. And then we have x times x. And this is actually called expanding, because if we just factored, we would leave this is x squared, but we're fully expanding. And you'll see why in a minute here. So x times y, and that gives us our numerator. Now let's do the denominator. So 10 divided by 2 is 5 times 5, and then times x times y times z. So now that we have our numerator and denominator factored, how we can simplify this is just cross out whatever is matching on the top and the bottom. And the reason why is because if we added the exponents, say we have here, we have x to the power of 1 and x to the power of 1. If we combined these and added the exponents, that would give us x to the power of 1 minus 1, which would give us x to the power of 0, which would give us 1. And so that's why we can cross it out when it's matching on the top and the bottom. But let's do that. So we have a 2 and a 2, cross that out. 5 and a 5, cross that out. An x and an x, let's cross that out. And then we have a y and a y. So that leaves us with a 2, an x, and then a z in the denominator. So we can write this as 2x over z. So that is our simplified version of the original fraction. But once again, you just have to factor and fully expand the numerator and denominator as much as possible. And then once we do that, we can cancel stuff above and below the fraction bar. So here's another example that we can simplify just by fully expanding the top and the bottom. So let's do that. We have a times x times over here x plus y times x plus y. Notice I left this in parentheses because we will be able to cancel it with the ones down here. And then for the denominator, we have x times our x plus y over x plus y. And so let's just go through and cancel. We have x here, x, and then x plus y and x plus y. So now we're just left with a squared over x. So that's our solution for this example. Pretty soon, you shouldn't even have to expand. You should just be able to see and look at it and just cross it out. So like you'll see, oh, have an x here, so you get rid of that. And then you'll just turn this into x over 1, and then you can just cross this out because it's 2 x plus y's, and then you'll know you just have a cubed over x. But as you're still learning, it's helpful to write it out sometimes. So I would find if you try just looking at it and you get a couple wrong answers, I would just keep fully expanding it before you cancel. This example is a little more tricky, but we can still solve it or simplify it using the same method. So let's just go ahead and factor the top and the bottom as much as possible. So for our top, we'll have we have a common factor here of z and also y. So we can factor yz out of the top. So if we factor yz out of the first term, that gives us x squared. And then if we factor it out of the second term, that gives us y squared. Oh, look at that. We have a difference of squares. But let's just do the denominator first. So we have, looks like we have an x, we have a y, and we have a z actually. So we can do x, y, z for common factors, and that gives us x for the first term minus y for the second term. So the only other thing we can factor is in our top here, difference of squares. So how do we do difference of squares? We just do, if we find the square root of the first term minus the square root of the third term, right? Or plus, and then minus the square root of the third term. How you factor difference of squares. So that is our numerator, our top. And then we'll just rewrite the bottom here, x, y, z times x minus y. Now, we're all factored as much as possible. We can go ahead and cancel. So we have a y here, I'll cross that out. We have a z, cross that out. And then we also have an x minus y. So we can cross that out. And that gives us, I'll bring it back up here, gives us x plus y all over z. And that is our solution for this example. Here's one more example. It's a little bit tricky, but there's one like this in the homework. So I wanted you to be able to know how to simplify this. Let's just break it down. Let's start with the top. So if we rewrite that as, you can see it's a difference of squares. So how do we factor a difference of square? Well, you just take the square root of the first term, which is a squared, plus the square root of the second term, which is b squared, times square root of the first term minus the square root of the second term. So that's factored. And then let's factor the denominator. Notice that if we need to, we can factor this again as another difference of squares, but I have a feeling that we're going to need to cancel an a squared minus b squared somewhere. But let's just see. So let's do the denominator. If we have over here, we have a perfect square, right? So we can just write this as, it looks like a plus b, right? A plus b squared. Square root of the first term plus the square root of the third term, because they both add up to 2ab. So we can write that as a plus b squared, and then here we have a squared, b squared again, plus b squared. So now, what should we do next? Well, this already will cancel, so we can go ahead and cross that out, and let's rewrite it as a squared minus b squared all over our denominator of a plus b squared. So it does actually look like we will want to factor this difference of squares, because we could cancel out an a plus b. So let's go ahead and do that. Difference of squares, it is the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term, all over our denominator of a plus b times a plus b right? So we can cross out an a plus b, and that leaves us with a minus b over a plus b. We cannot factor or simplify this anymore, so this will be our solution for this example.
Hey guys, if this video has been helpful to you, click the link in the description to get access to the complete Easy STEM Algebra 1 system, which includes a textbook, homework, and all of the course videos in order.